you learn how to speak the names of formulas that you see. So we're going in two directions here. You're going to learn how to write formulas when I give you a name, and you're going to learn how to name something when you're given a formula. So it's a bi-directional process. You go either direction. And of course today is the 20th. Okay, so we'll start off with some basics. What's a chemical formula? And there is a distinction between molecular and ionic compounds in how we name them. So with molecular compounds, there are those discrete, independent, individual units called molecules. And a molecule has a given number of atoms of each kind in it. And when you did your molecular geometry lab, those were all molecules. Those were things that were covalently bound. There are always 6 fluorides and 1 sulfur in sulfur hexafluoride. Now there's always 1 oxygen and 2 hydrogens in H2O. So a formula for a molecular compound shows the actual type and number of atoms in a single molecule, because you have that molecular unit. And the one that we use again and again and again because it's so much fun is glucose, C6H12O6. It actually literally has 6 carbon, 12 hydrogen, 6 oxygen. You know, it's not a ratio, it's not an approximation. That is a literal representation of the number of atoms in the molecule. And I think you all get that, you all know that. For ionic compounds, it's not like that. So for ionic compounds, because there is no discrete unit, it's a giant cluster of positive and negative ions all hanging out shoulder to shoulder. So what the formula shows is just the ratio of positive to negative ions. Okay? So in potassium bromide, KBr, it's a 1-to-1 ratio. And in calcium bromide, it's a 1-to-2 ratio. So those subscripts just show the ratio. A couple notes. You notice that there are no subscripts in KBr. If the subscript is 1, we don't put it in. So we don't show 1s as subscripts. Likewise, in calcium bromide, you'll notice that there is no subscript on the calcium. That indicates that there's 1 calcium for every 2 bromide ions. Okay, monoatomic ions. This is where we're going to start. And mono means 1. So monoatomic ions are ions that are made up of 1 atom. Duh. When we look, if you would be so kind as to grab your periodic table. So the main group are what? What block and what block? S and P. And S and P tend to lose or gain electrons in a really predictable fashion. So already you guys are, and I said you would get to a point where I could wake you up at 2 in the morning and say, what ion does this form? And you'd stagger awake, shake your head, and answer. This is where that happens. So you know that group 1 and 2 tend to lose electrons. They tend to form cations, positive ions. And group 1 loses 1, group 2 loses 2. So you now know that if it's group 1, it's going to form a +1. If it's group 2, it's going to form a +2 ion. When we get over 15 through 17, these guys tend to gain electrons. And they tend to gain to get up to that octet. So 15 they have 5 valence electrons. They tend to gain 3. 16 tends to gain 2. 17 tends to gain 1. Because they're all looking to be like a noble gas. The D block are the weirdos here. So if you remember in the D block, they have those S and D crossovers. And metallic bonding means that their electrons are what? What was the term we used? Swimming around in a sea, yeah. And the technical term we use is delocalized. But yeah, they're sort of unattached to a given nucleus. So we talk about the sea of electrons. Well, what that means is that those transition metals can form multiple ions. So they may form, and there are ones that they most commonly form, but they can form +1, +2, +3, +4. There are some that form +5 and +6. We don't really talk about those much. So at this point, I am going to pass out your new periodic table. As to look at the back of this page, what you're going to see, the first box is common main group monoatomic ions. And that's just a memory jogger. Oh yeah, group 1 forms this, group 2 forms this, group 15, 16, 17, and the two that form +3 and -3 ions, aluminum and nitride, are there also. Here's the wonderful news about this page that you're holding in your hand. This ends up, I started calling it the Ion Bible years ago. You get to use this on everything. You use this on your tests, you use it on your homework, you use it on your quizzes, you use this all the time. And you'll get really familiar with it. The first time I taught chemistry, I had students try to memorize all these ions, and I thought, that's stupid. Nobody memorizes the ions. You just keep using them until you know them like the back of your hand. Once you've looked up permanganate 463 times, you're going to know the permanganate ion. So you're just going to learn these by using it. You don't have to memorize them. You get to keep this page. I made 100 copies this morning. You will lose it. I will have extras. It's fine. You'll end up with like 6 of these. So the first top one is just your memory jogger for the main group. The next block is what we're talking about right now. That's those D block elements. And you'll notice that a lot of these occur in multiples. So chromium is a great one. You have chromium 1, chromium 2, chromium 3. Now, chromium 4 is apparent. Actually, I think there is a chromium 4. I got these from a number of sources. I kind of put it together myself using your book and some other chemistry textbooks. There is a chromium 4, I'm pretty sure. There's also a chromium 6. There are things that form +5s. These are the most common. It doesn't mean that if it's not on here, it doesn't exist. But these are the most common of the monoatomic ions from the D block. Those D block ions, you'll notice, have little parentheses with Roman numerals after them. That's important. That's what's called the stock system, and we'll talk more about it later today probably. But that's how we name them. So just so you know, you have a reference now that shows the common D blocks. Okay, so now we want to name these things, and we're going to practice some naming. Well, with cations, and cations are positive, those are just named for the element. If it forms a single cation, it's just named the whatever ion. So the two examples here, the sodium 1+, that's a sodium ion. Calcium 2+ is a calcium ion. It doesn't get a whole lot easier. So if I tell you I have, write down what that's called, K1+ is called. It's the potassium ion. Nothing changes in the name. There are no changes to the name. It is just the potassium ion. If I had the barium ion, whoops, okay, well I blew that one. Okay, Ba2+, what's it called? Barium ion, yeah. So for the cations where the element only makes one ion, it's very easy to name them. It gets a little bit more interesting when we get to the anions. And I want to preach the gospel of paying attention to endings here. So when you have an anion, the ending of the element name is dropped and it gets replaced with IDE. So Cl1- is not a chlorine ion. It's a chloride ion. And S2 minus is not a sulfur ion, it's a sulfide ion. So let's practice these, and of course you know I'm going to give you the worst ones. Well, I'll start you off easy. O2 minus, write down the name. That's an oxide ion. And we still say ion. Though often if we're in a hurry, we'll say, oh yeah, that's oxide. That's fine. But it's an oxide ion. Okay. Let's do Br1 minus. Jot it. That's a bromide ion.
How do we know how much to drop?
It's a great question. In most cases, part of me wants to say, well, it'll just sound right. Oxygen, bromine. In cases where the name was something like bromine, that little ending is the part that's getting dropped. In cases that are a little bit less regular, like oxygen, nitrogen, I guess in oxygen and nitrogen, in both cases, the gin is getting dropped. And honestly, part of it is just, you'll just get used to it, and they'll just sound right to you. And you'll probably screw it up a few times before that happens, but that's okay. We won't beat you up or hold your feet to the fire on that. So, okay, let's look at some of the weirder, trickier ones, because, those are my favorites. We'll move those aside. Let's look at what we would call N3 minus. Yeah, that is a nitride ion. Nitride ion. Okay, I1 minus is the one that everybody hates. Okay, somebody who is wearing something other than blue jeans, take it. Okay, that is the iodide ion. And there's our IDE. So here's the gospel of paying attention to endings. Right now, this is really easy. Starting soon, you will have IDE endings, you will have ITE endings, and you will have ATE endings. They mean different things. And you will keep them straight, all of them. So, you need to pay very close attention to this IDE. When you see IDE, this is a monoatomic anion. Okay? So, an IDE ending only goes with a I can't even spell monatomic. Monatomic. That's right, we dropped the O. Monatomic anion. Those things go together like peanut butter and jelly. Okay? So, the D block elements that you have the big list of on the back of this sheet, they get these Roman numeral designations, and we actually name the charge when we name the ion. Because we can't just say, oh, it's a copper ion. Oh, it's a chromium ion. We have to say what the charge is. So, Cu1 plus is called a copper 1 ion, and that 1 is given in Roman numerals in parentheses. Both of those pieces are important. Don't forget them. So if I had Cu2 plus, this is like who's buried in Grant's tomb. You know who's buried in Grant's tomb, right? Grant. It's yeah, Grant's tomb kind of question. What do you call Cu2 plus? Interesting thing, when we go to the Carnegie in April and we go to the mineral hall, you will look at some minerals that both get their coloration from copper-containing compounds in them. One is blue, one is green. The difference is copper 1 or copper 2 ions, because they show up in different colors when they oxidize. So, okay, so let's practice with, if I gave you Ni3 plus, jot down the name. So this is nickel 3 ion. Okay. Not hard. Not difficult. So the question came up, do we have to write the charge? In essence, you are. So there are two different things that you're doing here. This is it's basically the formula for the ion. This is the name of the ion. Okay? When you're writing the name of the ion, you are giving the charge.
What if it was negative?
It won't be for the transition metals. Transition metals are all positive. So, and that's, they always form cations. Okay. Bi means how many? Two. Binary ionic compounds are ionic compounds that are made of only two things. Two different elements. So, things that are true. Here is a little teeter-totter. This is a metaphor, but I like it. When you are writing a binary ionic compound, the overall number of positive charges has to equal the number of negative charges, because these are neutral substances. So the charges have to balance out. Now, in a case of something like Na1 plus, Cl1 minus, okay, easy. They just do, they balance. One sodium will cancel out one chlorine. Great. Well, when we get to things that aren't one-to-one, there is an easy way to write formulas for binary ionic compounds. I'm sure most of you did this in physical science, and for some of you it's probably just a little rusty. So, if I tell you that you have a compound made up of, we'll use calcium. Calcium ions and sulfur ions. Okay, and actually let's make that even better. Calcium ions and sulfur ions. Okay. Our very first step is writing the ions. So step one, write the ions. Calcium will form what? Somebody who has, I don't know, somebody who hasn't gone yet. Somebody who's writing on their shirt who hasn't gone yet. What does calcium form? So find it on the periodic table. What group is it in? Calcium forms Ca2+. What about sulfur? Yeah, and sulfur forms S2-. Your second step is to crisscross those charges. So now we always write the positive first as a matter of course, which means we're writing the metal first because the metals form positives. Calcium is a metal, don't forget. We crisscross those charges. So we rewrite these and we leave a little space at the bottom where our subscript is going to be. And the number, just the number, we're now just looking at the absolute values. This number is going to go down here, and this number is going to go over here. That's called crisscrossing. That's the crisscross method. That's all there is to it. And then what that would give us is Ca to S2. Now our last step is to simplify if possible. So Ca2S2 becomes what? So that becomes CaS. And that's an ionic compound made up of calcium ions and sulfide ions. Okay. So let's try one that's not a beautiful, simple little ratio. Let's do strontium fluoride. That's some nasty stuff. So something made up of strontium ions and fluoride ions. We'll set this one aside. Okay. strontium ions and fluoride ions. Okay, first step, write your ions. Strontium forms what? Strontium is Sr. 2 plus. So we have Sr, 2 plus, and fluoride forms F1, 1 minus. Okay, crisscross your charges. So first we're going to write these down here in such a way that we have space. Crisscross them. And what we end up with is SR1, F2. If we simplify, what happens to that 1, we said? It disappears. We don't show 1s. So we end up with SR, F2. And that would be our final answer. That would be the ionic formula for a compound made up of strontium and fluoride ions. Okay. So we're going to practice this in reverse. What you've just done is formula writing when you're given a name, in essence. Well, actually, no. You know what? Let's go back to making sure that we can do it from names. I was giving you sort of a setup, like, oh, okay, a calcium ion and a fluoride ion. But let's do this from actual names. So beryllium chloride. Terribly written, I apologize. Okay, when you're just given a name, we start with that first step. We write the ions. So we're looking at beryllium forms what ion? Oops. Form. So beryllium would form a Be2 plus. What's the chloride ion? Cl1 minus. Second step, we write that out. We crisscross our charges. So we would have Be1Cl2. Third step, we simplify. So what does that end up as? BeCl2. That's beryllium chloride. Okay. Okay, for potassium sulfide, what ion does potassium form?
I had a question before that.
Oh, okay. Yes.
Does it matter what order they're in?
Yes.
Okay.
Absolutely. Positive ion always comes first. Always, always, always. And you can remember that by like lead with the good news. Lead with the positive. Okay, so potassium sulfide. What does potassium form?
K1.
Yep, K1 plus, and the sulfide ion is S2 minus. So when we crisscross those charges, we get K2S1. And when we simplify, step 3, we get K2S. Okay? Magnesium nitride. So, what ion does magnesium form? Mg2 plus. Nitride is what? N3 minus. Our second step, Mg with a little gap, N with a little gap. When we crisscross our charges, these are actually my favorites. I just like them. I don't know why. So we get Mg3N2. Any simplification possible? Nope. Mg3N2 it is. I love the 3 2s. I don't know why. I just think they look nice. Okay. So at this point, what you should be able to do, and we're gonna stop with the monoatomic ions, and I'm gonna give you time to practice while I float around and kind of look at your mistakes. Not that you're gonna make them. That's okay. That's how you learn. That's how you become an Olympic athlete. Not by going to the Olympics. So at this point, you should be able to do the following. You should be able to name the compound from the formula. So when I show you NaCl, that's what? Sodium chloride, because we know that these are named from the ions. If I show you MgCl2, what's that called? Magnesium chloride. Easy for you to say. There is no hint in the name magnesium chloride that there's a 2 there. Because in ionic compounds, we don't reference those subscripts in any way. With straight monoatomic ions not formed from D block. So that's just magnesium chloride. The stuff that we did on the last page, the magnesium nitride, Mg3N2. Those subscripts are not referenced in the name. You're just naming the ions. So the name of a monatomic or of a binary ionic compound is just the names of the ions. Always the positive first, always the negative last, which means you always have that IDE ending. Okay? So let me give you some homework stuff to practice on, and I will float and help.